So welcome back to the channel. So if you haven't subscribed, so please subscribe to the channel. So in this video, you'll be learning the rules to draw the ray diagram for lenses. We can represent the image formation by lenses using the ray diagram. So this ray diagram helps us to study the nature, position and the size of the image formed by the lens. So in order to draw the ray diagram using lens, so first there are some rules which you have to learn. So in this video we'll be learning the rules to draw ray diagram for lenses. So here is the rule number 1. When the light ray is incident towards the optic center, it passes undeviated through the lens. So here first I have taken the concave lens. So this is the concave lens. And as you know, the center of the lens is called as optic center. So the exact center of the lens is called as optic center. The first rule states that when the light ray is incident towards the optic center, it passes undeviated through the lens. So we'll see how is it. So first I have taken a concave lens. So first I'll mark this point as focus point F1. I'll name it as F2. Now what I'll do, I'll place an object. You can place wherever you want. So I'll be placing here beyond F1. So now I'm placing the object. I'm indicating the object using arrow mark. So I'll name this as A and I'll name this as B. So AB is our object. Now we have taken a concave lens. So the rule states that whenever the light ray is incident on this lens, when it passes through the optic center, it passes undeviated. See, this is the object AB. Now what I'll do, I'll draw one incident ray which is coming from the object. See, I'm drawing one line. It should start from this object. So that is object AB and this incident ray. So this will be the incident ray and this incident ray should pass through the optic center. Now I'm drawing a line which is passing through the optic center. When the light ray is incident towards the optic center, till we have done, it passes undeviated. So it follows the same path. It will not deviate. It will follow the same path. So when the light ray is incident towards the optic center, it passes undeviated. So this is the rule number 1. So whenever the light ray or the incident ray passes through the optic center, it passes, after passing through the lens, it passes undeviatedly. It will pass through the straight same path. Fine. So now we shall take a convex lens. In the convex lens also the same rule is applied. So now I'll mark this as F1 and this point as F2. So now what I'll do, I'll place the object wherever you want, you can place. So now what I'll do, I'll place it here. Okay. So now I have placed an object. So I'll name it as A and B. Now we are drawing the ray diagram for the rule number 1 using a convex lens. So same thing. Now the incident ray which is coming from the object, that is AB, will pass through the optic center. So now what happens? Yes, it passes undeviated. So it will follow the same path, its original path. So the object AB, so when the incident ray, this is the incident ray, passes through the optic center, it passes undeviatedly. It will pass through the same own path, that is straight. So this is rule number 1. So this is for concave lens and this is for convex lens. So hope you have understood rule number 1, that is when the light ray is incident towards the optic center, it passes undeviated through the lens. So now we shall move on to rule number 2. So here is rule number 2. all rays which are parallel to the principal axis after refraction passes through the principal focus. So as you all know, this horizontal line which is passing through the optic center is called as principal axis. So this horizontal line indicates the principal axis. Here this rule 2 states that all the rays which are parallel to the principal axis after refraction passes through the principal focus. So first I'll mark the focus points. So now I'll name it as F1 and I'll name it as F2. First what we'll do, we'll place an object. So in order to place an object, I have to draw a vertical arrow mark. Okay, so now we shall name it as A and I'll name it as B. So now the rule states that all the rays which are parallel to principal axis. So now what I'll do, I'll draw a line which is coming from an object and it should be parallel to principal axis. Yes. So now we have written a incident ray which is coming from the object and it is parallel to principal axis. This incident ray is parallel to principal axis, and what you have to do is you have to draw the dotted lines to F1 because in the concave lens the image is formed at point F1. So always in concave lens the image is formed on the same side. So what you have to do, from the object, you have to draw a parallel line which is parallel to principal axis. So now what you have to do, you have to place your scale such that you can draw dotted lines at the principal focus, that is F1, and then you can draw a normal line like this. You can extend the normal thick line towards this side. So what you will do, the parallel line which is coming from the object, it should be parallel to principal axis. So after refraction, it passes through the principal focus. So in case of concave lens, this will be the principal focus. So now what I did, I have placed the scale such that I can easily draw the dotted line towards the principal focus, that is F1. Without changing the position of the scale, here I have drawn the normal line. So here the image is formed at the principal focus. So this is how the rule 2 states in case of concave lens. Parallel line which is parallel to principal axis, then you will place your scale and you will draw dotted lines towards the principal focus, that is F1. Without changing the position of the scale, you will draw the normal line. So this is the diagram obtained. So when you apply the rule number 2 for concave lens. Fine. So now what we'll do, we'll apply the rule number 2 for convex lens. So this is the optic center. So I'll mark this has F2 and this has F1. So here I have taken 3 centimeter distance from O, that is optic center to F2. From O to F1 also I have taken 3 centimeters. So that I can get the proper image. You can use the scale and you can use the proper measurements. Okay, fine. So now what I'll do, I'll place the object. You can place wherever you want. So I'll place it somewhere here. I'll name the object as A and B. So I've named it as A and B. Now what I'll do, I'll draw a parallel line which is coming from the object and it should be parallel to principal axis. Now from the object I have written a line, I have drawn a line. So this will be your incident ray and incident ray should be parallel to the principal axis. So now after passing through this convex lens, this ray will pass through the principal focus. So the principal focus is F2. Right? So you can draw the dotted lines here also so that you can know where the refraction is taking place. Right. So now we will draw object first. You'll name it as AB. Then from this object, you'll draw a parallel line to the principal axis. So after refraction, this line will pass through the principal focus, that is f2. Hope so I have made it clear. So this is rule number 2 for concave lens and convex lens. So for concave lens, so f1 will be the principal focus, and for convex lens here f2 will be the principal focus. This is about rule number 2. So now we shall move on to rule number 3. So rule number 3 states that a ray of light passing through the focus after refraction becomes parallel to the principal axis. The ray of light passing through the focus after refraction becomes parallel to the principal axis. So first we'll learn in case of concave lens. So here I've taken a concave lens. For 3 centimeter I'll be writing f2. Here I'll be marking it as f1. So these are the focus points. So now according to the rule, when the ray of light passes through the focus after refraction becomes parallel to the principal axis. So now what I'll do, I'll place an object here. I'll name it as A. I'll name it as AB. So this is the object. So I've just extended the line. So this is the object AB. Now what we'll do, we'll draw a line, incident ray, which is till half of the lens. We'll draw the normal line. From there we'll draw dotted lines to the point that is focus, that is f2. So what we'll do, from the object you will draw the normal line till here, that is till the concave lens, and after the it reaches half of the concave lens, what you'll do, you'll draw the dotted lines to the principal focus f2. According to the rule 3, the ray of light passing through the focus after refraction becomes parallel to the principal axis. So after refraction it becomes parallel to the principal axis. So now from here what I'll do, I'll draw a normal line which is parallel to principal axis. So this is the image formed. So from object AB, what you'll do, you'll draw a normal line. You have to place your scale such that when you draw the dotted lines in backward direction, it should meet the point F2. You have to place your scale such that when you draw dotted line when you draw the dotted lines, it has to meet at point F2. So the normal line to half of the concave lens. After refraction, you have to draw the dotted lines, because always the image formed is virtual in case of concave lens. So we'll indicate with the dotted lines. And according to the rule 3, the ray of light passing through the focus after refraction becomes parallel to the principal axis. So it becomes parallel to the principal axis. The ray of light passing through the focus after refraction becomes parallel to the principal axis. Right? Yes. Fine. This is for the students or for the people who have not understood the rule number 3 properly. So I'll teach you with one more diagram. So what you have to do is, you have to draw an object, that is AB. You can place the object wherever you want. So now I have placed it here and I have named the object as AB. So now according to the rule, the ray which is coming from the object after passing through the principal focus and after refraction, it moves parallel to the principal axis. So what you can do is, you can draw a line like this and you have to place your scale such that this, if you draw a line, it should pass through the focus, that is F2. It should pass through the point F2. So what you'll do, you'll place your scale such that the line, the incident ray which is coming from the object AB, till half of the lens you have to draw the normal line. And what you can do is, you can straight away from this point, what you can do, you can draw the parallel line which is parallel to the principal focus. So this is also right, and even the previous one was also right. You can draw either like this, or else if you are confused with that method, you can draw like this. What you will do, you will draw object, you will place an object like this, and from the object you have to place your scale such that the line, if you draw a line, it should pass through the principal focus f2. First, what you will do, you will draw a normal line till here, till half of the concave lens. After this, after refraction, it will be parallel. So what you will do, you will draw a parallel line. From this point, you will draw a parallel line which is parallel to the principal axis. So hope so you are clear with this. If you are still having doubt, you can rewind the video and you can clear your doubts. Fine. So now we shall apply rule number 3 for convex lens. So first I'll be marking the focus points f1 and f2. I'll divide this lens into halves so that you'll not get confused. So now I'll place the object here. I'll name it as AB. You can name whichever alphabet you wish. So I have named it as AB. So now, according to rule number 3, so when the light ray passes through the principal focus after refraction, they will be parallel to the principal focus. Same thing. So F1 will be our principal focus. So from the object, what I'll do, I'll draw a line which passes through the principal focus f1. From the object, I have to draw a line which passes through the principal focus f1. So after refraction, what happens to the refracted ray? Yes, it will be parallel to the principal axis. So now after refraction, it will be parallel to the principal axis. So this is our refracted ray. So now you have placed an object AB. From the object, the incident ray, when the incident ray passes through the principal focus, that is f1. So after refraction, the refracted ray will be parallel to the principal focus. This will be the refracted ray which is parallel to the principal focus. So when the incident ray passes through the principal focus, after refraction through the convex lens, it passes parallelly. It emerges parallel to the principal focus. Hope I made it clear. So this is about rules. These are the 3 rules. You can use any of the rules in order to draw the image formation for different position. We'll be placing the object in different position and we'll be drawing the ray diagram. So you can click on the I button to learn how the image formation can be done. So enough for the video, children. So hope you have understood. If you are having any doubts, you can leave your comments in the comment section. So I'll try to clear it out. And if you haven't subscribed, please subscribe to the channel. And please do share this video to your friends. And thanks for watching. Thank you.